In this video, we're going to convert my wife's bike from a one-piece crank to a three-piece crank. So when I was a kid, just about all bicycles had these one-piece cranks. It's just a single piece of forged iron, and it's got bearings that run in here, and those bearings run against this piece of stamped metal. The problem with this arrangement is that piece of stamped metal isn't perfectly smooth and it's not hardened, so the bearings don't roll quite as well as they would in like a sealed bearing type of an arrangement. If you're only going for a short ride or maybe around the block, the difference doesn't really matter, but many times we're going for afternoon rides, 20 miles plus, and after 20 miles it's definitely something that you would notice. So even on cheaper bikes, similar to this one from Walmart, or this one from Walmart, or this one, I'm assuming from Walmart or another big box store, they've moved to a three-piece crank. Unfortunately, the advantage of a three-piece crank is still lost. On nicer bikes, there's a cartridge that goes inside this shell here, and that cartridge has two sealed bearings that they're going to give you your best resistance to friction. However, on these cheaper bikes, they still have the same sort of an arrangement. There's a steel piece in there that's not very nicely machined, and loose bearings that really don't roll very well. Certainly they don't roll any better than the bearings in a single piece crank. So off camera, I went ahead and cut this bottom bracket off of this bicycle. Now, this is a bicycle I used a lot of tube and parts from to make the swing bike, by the way. And while this crank has individual bearings that just ride inside these parts that may be machined, although probably not too well, this piece of steel here, this bottom bracket, does offer me the size and the threaded inserts here, or the threaded portions here, so that I can go ahead and install a cartridge. As it turns out, this bottom bracket is frozen in there pretty well. I'm not absolutely certain this will work, but I'm going to go ahead and give it a try and see where we end up. Removing this nut and this pedal, just keep in mind that they're reverse thread on the side of the bike, so you have to turn clockwise to loosen them. So I went ahead and removed the crank and popped one of these cups out, one of these bearing cups with a hammer and a socket. It was in there pretty good. And the concept here is that I'm going to weld this bottom bracket into the cup here, obviously then install that cup, or this whole assembly, in there, and then also weld it on the other side. Checking the idea of this bearing cup compared to the OD of this shell, looks like I'm going to have to take about 10 thousandths of material off the inside of this. So I'll just use a drum sander. That should get me close enough pretty quickly. Also, I'm going to have to clean off a bunch of these welds. They're going to be in the way. One other thing I'll have to keep in mind too is, just like on the old bike, this bike has got a piece that's reverse threaded, and I need to make sure that I get this in here so that I got my drive side on the correct side. I go through the trouble of reverse threading these so pieces don't fall apart as you pedal due to the friction of it. So I got to make sure that I maintain that integrity. I'm sure it'll work even if I don't, but it'd work out better if I do this properly. So I guess this would be considered a redneck lathe. I've chucked this thing up in my drill press, and I'm just kind of hitting it with the grinder as it turns, and seeing if I can get like a reasonable smooth surface here. Alright, so that was super sketchy, but I got my cups fitted, so, and there's nice small gaps here, so that's going to help with the welding. Also, I checked the other bikes, and this side with this jam nut, I guess, or whatever you want to call it, that's the non-drive side. In other words, the side that's not on the chain side. So this is the chain side. It's going to be important for me to make sure I keep that straight. Well, these old bearings are pretty crusty, the bottom bracket. I guess that's why this one didn't turn anymore. Lots of rust, bearings are falling out, pretty bad shape. Luckily we didn't need this part at all. I'm going to replace it with a cartridge bottom bracket. Well, I've got a change of plans here. There's no way I'm going to be able to weld in there. It's way too deep, way too narrow. I can't get that arc down in there and be able to weld. So what I'm going to do is I'm going to go ahead and weld this cup on the outside here. The other cup will just be a support, but it's a tight fit, so I think that's going to work out just fine. Obviously, since those cups have to be pressed into this shell here, there's no way I could weld the other cup because it's going to be on the inside here. It's not inaccessible. With both the cup and the shell resting on this flat piece of steel, I think that we're going to be good enough as far as that being perpendicular. Obviously, if this is off at an angle, then it won't meet up with the other cup inside of the shell there. Well, that weld came out pretty well. I went ahead and spotted it in one spot, and then 180 degrees, and then 90 and 90, and then went ahead and completed the weld. As I said in my last video, over on the channel Make It Custom, Carl Fisher over there said that if you want your TIG welds to come out better, then you need to have a smaller gap, lessen the material thickness, and that has had better results for me than any other piece of advice I've gotten online so far. So anyway, I'm going to go ahead and get this brushed up, get a coat of paint on it, and we'll stick it on the bike and see how it works. So I'm getting ready to press these cups back in here, and I'm using little pieces of scrap plywood. Two reasons here. First of all, to distribute the load, and then also I don't want to booger up these surfaces. Prior to just banging it in with a hammer, I could get the pieces in, but you know, we got those threaded surfaces in there, and you know, hitting it with a hammer is going to wreck those. So I'm just turning slowly because inside here, that piece that I welded is in here, and it has to make it into the hole in this cup. But seems to be lining up just fine. So I have these cups pressed in, and I guess now's the time when we find out if this is going to be a really great idea or not. So, you know, I got to get that cartridge in there, and then we've got to make sure that all our clearances and everything are going to work out. Get to find out whether the chain's going to be the right length and whether we can make that work. So this is where it gets interesting. So I have this cartridge came off another bike. If I remember right, we swapped the cartridge, and it turned out that we're getting a creak from another spot. So it's a used cartridge, but it's in good condition. So when you install your bottom bracket, one side is threaded in, and then on the other side there's a cup that kind of holds this snug, and it's not wanting to go in all the way. I guess the threads are a little bit boogered up. So there's a little trick I learned, and I'll show you how that works. So we could certainly get a tap for that to chase that thread out. That's going to be a really, really expensive tap. And we're only looking to chase the threads. And, you know, this is like something we use once or twice or 3 times. Not very often. So we're going to sacrifice this old part that came from that bottom bracket. And we're going to make a cut in here. And, you know, with the angle grinder, this is standard thread. So as you're turning this in, you want to make a cut a little bit angled from diagonal this way. And by doing that, you can actually cut this in such a way that it will actually chase those threads, similar to a tap. Obviously, this is not going to be anywhere near as durable as a tap, and you can't cut threads this way, but you can certainly chase them. So that little cut in there, just like that, when you thread that in, gives it a little place for the material to go that you're kind of pushing away. In this case, some rust and debris. And actually works pretty good. Once again, not as well as a tap, but you know, that was a piece of garbage I was going to throw away anyway. And I would imagine that a tap of that size would probably cost me 40 or 50 bucks at the very least. So now I'm able to get that spacer in all the way. Still a little bit of resistance. Once again, I mean, it's not a perfect cutting tool, but instead of having to force that and, you know, possibly break something, here we are, and you know, and that sits in there nicely. By the way, installing these bottom brackets requires a special tool here, but they're inexpensive on eBay. Also, if you're not familiar with these bottom brackets, you got to be really careful starting them up, because with that big diameter and the fine thread, it is more easy to get that cross-threaded than it is to get it in there properly. So you got to be really, really careful. Don't get in there with that tool right away. Make sure you can get a couple turns in by hand first. So that's our first hurdle cleared. There's no interference with the frame, kickstand. I guess I'm still wondering if I'll be able to get the chain guard back on, but let's see if how the chain's going to fit. Well, the chain's got quite a bit of slop. I guess this first ring is quite a bit smaller than the one that we took off, but we can adjust that easily enough, I'm sure. Unfortunately, we weren't able to retain these pedals, which I think are cool beach cruiser pedals. So we went with these other plastic pedals. That's the way it goes, I guess. Change of plans again. One of those other pedals was no good, so I'm going to go with this pair. Look kind of cool, I guess, for a mountain bike or a BMX bike. Not quite a cruiser, but I'm sure we can live with it. Alright, so let's give this a try. See if this runs any better. I've got the chain guard on. Everything is working nicely. The only thing I had to do to the crank is it was a 3-arm or a 3-cog, and I did remove the outer cog to get this to fit with the chain guard on. But I think that the chain guard is important, if nothing else, for the look of the bike. So anyway, I guess that little project was a success. One other thing, you know, a lot of people have bikes that they got from Walmart, and my experience is that actually they're not bad bikes, but they do need a lot of adjustments. The bearings aren't adjusted too well, and they could use some grease. And probably one of the biggest things you can do to improve your Walmart bike, if you have one, is go ahead and put a cartridge bottom bracket in there. It really makes a huge difference. Thanks for watching my video. Leave any thoughts, comments, or suggestions in the comments below. Have a great day.